Okay, this video goes over the inverse property between logs and exponentials. And there's a couple of different ways that we can ask you guys to use this particular inverse property. If you have your intro to log notes handy, then we've already done several problems that just simply asked you to rewrite your exponential and log expressions back and forth into the other forms. So for example, if I asked you to write 9 cubed is 729 in its log form, then what you would say is log base 9 of 729 is equal to 3. Another one, same direction, would, if I asked you to do 25 to the power of 0.5 is equal to 5, which of course is true because 25 to the power of 0.5 is the square root of 25. The log form of that would be log base 25 of 5 is 0.5. And so you guys did, I think it was 3 problems just like that on the intro to log notes. And then you also did 3 problems that went the other direction. So if I gave you this log base 2 of 32 is equal to 5. The reason that log base 2 of 32 is 5 is because 2 to the 5th is 32. And so we can go from the log form to the exponential form. So if we did log base 3 of 1 over 27 is negative 3, that's because its exponential form tells us that 3 to the negative 3 would be 1 over 27. And so that's how we've used this property before. And we've used it in lots of other units as well, where we actually switch x and y to find the inverses, which is technically what we've been doing. I mean, if I said 9 cubed is equal to x, then, you could even say 9 to the power of x is equal to y. And then you could put it in its log form, and its log form would say log base 9 of y is equal to x. Okay, but we've done this in other units as well, where we switch x and y to find the inverse. So what that means is that we can take more complicated exponentials and logs and find their inverses. So let's try one. If I gave you this equation, f of x is 3 times 2 to the power of x plus 5. And I said, find its inverse. Okay. Remember that the first step to finding the inverse is switch x and y. So what you would need to remember is that this f of x right here is just a fancy name for the y. So what this equation is really saying is y is equal to 3 times 2 to the power of x plus 5. So step 1 is going to be switch that x and y. So it becomes x equals 3 times 2 to the power of y plus 5. And then technically it's the second step. Usually the second step involves lots of other little mini steps because the second step is to isolate y. And so usually that requires moving multiple things to get y by itself. Okay, so what we would do first is we would subtract the 5 And so we would have x minus 5 is equal to 3 times 2 to the y. Then we would divide both sides by 3. Remember, we have to get the exponential by itself. So we now have 2 to the power of y by itself on the right side. We have the exponential isolated, and we can leave the left side written like this. And now we can convert it to its log form. And so if it says 2 to the power of y is that fraction, then as a log, it would say log base 2. And then everything else switches sides of the equation. And there's lots of ways that different teachers have talked about this with you guys. Of course, there's the lasso, the loop-de-loop method. If you want to know how to convert, you would take this and lasso around, and it would tell you what order to put it in its alternate form. One thing that I tell my kids is, and it's kind of an annoying phrase, but the base is always the base. And so if you remember that the 2 is always going to be what's on bottom and everything else just switches sides, that accomplishes the same thing. Okay? But this is what you end up with. And then the one thing you would need to remember to do then at the last minute is you would need to remember to use your inverse notation. And it is a function, so you could go ahead and call it f inverse of x. Or you could just leave it as y inverse. Okay, but you want to make sure you include your inverse notation. So the last problem is going to go in the other direction. So if I gave you f of x is log base 7 of x plus 4 minus 3. And once again, I said find the inverse. Okay, in order to switch x and y, we would need to remember that this is just a fancy name for y. So our equation is really y equals log base 7 of x plus 4 minus 3. And then step 1, switch the x and y. So it would become x equals log base 7 of y plus 4 minus 3. And then step 2 would be to isolate the y. And in order to do this, what we would need to do first is add the 3 to move it over. We need to get the log isolated. So we have x plus 3 is equal to log base 7 of y plus 4. Then we need to convert it to its exponential form. So the base is the 7. And then the y plus 4, sorry, that's what happens when you read equations backwards. So the base is 7, and then the x plus 3 and the y plus 4 switch sides. So the y plus 4 is not on the same side as the 7 anymore, and the x plus 3 now is. Or do your lasso. Okay, go through here and loop around. Okay, and now your last step to getting y by itself would be to subtract the 4. And so you have y, and don't forget that once you've isolated that y, you're now found y inverse, right? And it is 7 to the power of x plus 3 and then minus 4. Okay, and because this is still, yet again, a function, you could also call this one f inverse of x. Okay, so the practice problems that are optional, but we would like you to try before we give you your actual assignment later, excuse me, in the week. I want you to try finding the inverse, and I'm going to give you 2 of each kind, 2 exponentials and 2 logs. So you're going to find the inverse of these. Okay, so here's the 4 problems to try. F of x is equal to 4 times 5 to the power of x minus 12. F of x equals log base 4 of x plus 1 minus 7. F of x is 5 times 3 to the power of x minus 4 plus 9. And last but not least, f of x is log base 12 of x minus 6 plus 2. Okay, so give those a shot and we'll be glad to help you guys anytime you need it. Thank you.